This question belongs to the subject algorithms and was asked in CAT CSE 1988. So the question states quicksort is dash efficient than heap sort in the worst case. So it's basically a fill in the blanks question, fill up question. So what can be possible option over here? Quicksort can either be less efficient, or it can be more efficient, or it can be equally efficient to heap sort. So in the worst case, so let us analyze what happens in the worst case. So quicksort worst case occurs when the elements are in the sorted position like 1, 2, 3, 4, ascending order or descending order 4, 3, 2, 1. We will analyze both of them. So here partitioning occurs and we assume a pivot. We can assume it to be any item, but let us assume the first element to be pivot. Then all the elements less than pivot will come on the left, nothing is left less than 1, so nothing on the left. All the elements more than pivot will come on the right, so 2, 3, 4 will come on the right, not necessarily in the same order. Then again 2 will be taken as pivot, less than 2 is nothing, so nothing on the left. 3 and 4 on the right. 3 will be taken as pivot, less than 3 nothing on the left, and 4 on the right. So what happens is if we have numbers 1, 2, 3 up to n, then 1 will be taken as pivot, so nothing on the left, and all the elements from 2 to n on the right, so n minus 1 elements on the right, and same goes on. So if Tn is the time complexity to solve this entire quicksort, then partitioning take order of n, and this n minus 1 can be solved in T of n minus 1. So the overall complexity comes out to be order of n square in worst case. Let us analyze another worst case which can happen. So here any item can be taken as pivot. Let us assume 4 is taken as pivot, then less than 4 on the left, more than 4 on the right. Less than 4, everything is less than 4, 3, 2, 1 on the left. Nothing is more than 4, so nothing on the right. Then 3 is taken as pivot, less than 3, which is 2 and 1 on the left, nothing on the right. Then 2 is taken as pivot, less than 2 is 1, and nothing on the right as nothing is more than 2. So here if we have items from n to 1, then n is taken as pivot, and all the items from n minus 1 to 1 will come on the left and nothing will go on the right. So complexity would be T of n equals to T of n minus 1 to solve this problem, as it has n minus 1 items, and order of n for partitioning. So time complexity comes out to be order of n square in the same worst case. Now let us see how that works. Heap sort will work. So what is a heap? Heap is basically an almost complete binary tree, or we can say ACBT. So what is an ACBT? It will be a binary tree, which means each node will have at max 2 children, 0 child, 1 child or 2 child, and all the levels will be completely filled except the last level. The last level will be filled, maybe partially filled, but will be filled from left to right. So what is the height of an ACBT? Height of an almost complete binary tree is order of log n base 2. And let us now analyze what is a heapify operation. So heapify operation basically means removing an item from the top, replacing it with a leaf item, and then performing the heapification from top to bottom. It's called heapify top. So what will be its complexity? As the height is log n, so heapify take order of log n time. And during heap sort, we perform heapify n times. So the complexity for heap sort will be n times heapify operation. Heapify is log n. So complexity for heap sort is order of n log n every case. So in the worst case too. So heap sort takes order of n log n, and quicksort takes order of n square. So n square is asymptotically greater than order of n log n. So quicksort is less efficient as it is taking more time.